I'm not going to be talking directly about new technologies today, nor will I be the expert here in this room on computation or robotic innovations. But as a practitioner and as a professor that's teaching in the kind of foundational courses of an architecture school, who had also once upon a time, in fact, studied computational design, I'm going to talk a little bit about the skills and philosophy maybe that we need to have to think about what to do as we engage with technologies in the future. Because a robot is only as good as the input that's given to it. An algorithm is only as good as the programmer who imagined it. So like Carla was saying before, I think this kind of relationship between who's actually putting these parameters in place is actually a very important thing to consider. These machines operate within this world that we construct for them and these relationships that we set up. And that begs to question, what are we going to ask of them? Okay. According to numbers released by the Environmental Protection Agency, the EPA, in 2018, the construction industry generates over 600 million tons of waste every year, and that's just in the United States. It's projected that by 2025, global construction waste will reach 2.2 billion tons. We, of course, know that this is not simply a financial cost. It's an ecological one. Material waste largely ends up in landfills that further pollute the environment, but material waste also means that we had actually extracted resources beyond what was needed. We can't think of the future of construction without contemplating what this means and how we can not only reduce construction waste, but also not generate waste to begin with. We know this symbol quite well by now, reduce, reuse, recycle. This was designed and promoted in the 1970s. And for the last 40 years or so, we somehow thought this doesn't really apply to architecture or the construction industry, that this slogan is mainly, for aluminum cans and PET bottles. But of course, there's pioneers in the industry, designers and manufacturers, many of you who are in this room, that were trying to apply these principles. But despite all of that, the construction industry changed very little. In fact, when you go to a construction site today, with the exception maybe of a few iPads that might be loaded up with some BIM models, very little is different from what construction sites were in the 1950s. And this, we're showing, is in an advanced, technologically advanced country, the United States. So to reduce material waste really means maybe to call into question what we think of as waste. We're not just talking about waste from cutoffs or inefficient use of materials, but also from demolition. We need to dramatically rethink what we consider to be our material resource. Renovating a building, the adaptive reuse of a building, has been around for a while, and yes, we need to continue to do that, and maybe even with greater intensity. But there will also be times when we need to build new. Now, what could we do better in those moments? Not only in anticipating the kind of eventual reharvesting of the material, but also in anticipating change and really prolonging or extending, let's say, the lifespan of a building. The ways in which we've traditionally built, there was really no conscious consideration of how materials could be more easily reharvested or how our buildings could be reused. This is, also we need to re-examine this kind of conceptual basis of our design. How things come together means also how things come apart. It isn't enough simply to choose better materials or to apply a kind of technical solution at the end. We need to deeply rethink our design process and our design priorities. Rather than treat all buildings the same as sort of static, unchanging products that we deliver, we need to think of them as infrastructures that can be resilient, adaptable, reusable, and maybe even demountable. There isn't a one-size-fits-all solution. Instead, we should be more attuned to the demands that a building might face and to its future potentials. We need to consider these different life expectancies of a building's components as a way to kind of rethink what those layerings and compositions and assemblies might be. And to do so, we need to think and work collaboratively as architects and engineers to offer holistic approaches that tackle climate, structure, and space as integrated solutions that last for the lifetime of a building. This is an approach that we've been focusing on in our office for some time, and have had the opportunity also to test in different degrees, let's say, in our built work. Thinking of disassembly is something that's relatively new. We first actually encountered it in this project in Switzerland in 2013. By then, it was actually our third project that was going to be built for a public client, when this term in German, Systemtrennung, or system separation, was beginning to be sort of thrown around. And since then, we've kind of dealt with this full spectrum of what that means. And here it's a little bit unexpected because you look at this building and you don't think of it as necessarily something that wants to come apart. And in fact, the idea really was to design a long-lasting primary structure with recycled concrete, one whose mass would offer thermal inertia, low-tech solutions for comfort, such as natural ventilation, daylight, things like that. And the structural sort of durability of this primary structure will then be complemented by secondary and tertiary elements, systems that would be easily disassembled so that could adapt to, let's say, the changing needs of the inhabitants. At the other end of the spectrum was this project, which we finished after a very, very long incubation period, but also different phases of construction. This is an archaeological center that we had designed, also won through a competition, to be built on top of ruins. And so we had to make sure from the project brief already at the get-go that the kind of historical Roman city that was underneath of this building would still be intact if in 50 years they were to deconstruct the building and excavate underneath. So we really had to deal with the idea of disassembly and also recyclability from the get-go. And also, of course, also to find a way for these demands to be a kind of architectural expression. Flexibility and adaptability have to be built into the design. Otherwise, you end up with buildings that really become obsolete quite quickly. And these might seem like purely sort of engineering problems, but I would argue that they're in fact deeply architectural. We're trained to give meaning to space by taking into account all these different factors that affect it. And now, more than ever, we need to make use of that systems thinking to see relationships from one scale to the next and from one system to the next to understand also the limits of each. So in the first two examples, we were looking at, more or less sort of single material solutions. First, let's say a predominantly concrete building, and then in the second one, a steel building. But if we're truly to understand the performance of the structure and to minimize resources, our best efforts might be to go hybrid. So this is a proposal that we did for the SNF, Swiss National Science Foundation headquarters. That was also a kind of selective competition where we were first testing these ideas of a hybrid structure. We minimized the use of concrete to a very simple skeleton frame that would provide stiffness and robustness while being very, very material efficient. And the slab, which actually is where we would have usually the most concrete being used, would actually be then timber glulam infills. And this hybrid system also extended as a concept into the building itself as a kind of a hybrid low-tech sort of solution with cooling and ventilation concepts inside of these bioclimatic courtyards that actually became kind of the lungs of the building. So they would offer sort of fresh air, reducing also the machinery, the ductworks, and the energy use of the building. And all of that would then come together in a kind of architectural whole. And that, in a way also manifests itself into the kind of architectural or spatial experience of the building. So unfortunately, we did win this competition, but that got us started into thinking about certain possibilities and conversations with structural engineers that we worked with. This is the same structural engineer, Śnieżka Puszkas, that we worked with in the last project that we showed, and this one we actually did win. This is the Basel Innovation Labs that was competition in 2021, and we're essentially planning that now to be completed for 2028. So this is a project with a relatively new typology of rental lab spaces, if you want to think of it kind of like a co-working for chemistry lab startups that's pioneered by the city of Basel. So you can kind of imagine a little bit the contradiction here, because labs, as we know, are very cumbersome. They have a lot of infrastructural needs, services that you have to bring to it and things like that. And really, they don't want to change that often. And in this case, we were asked to think all about change, right? So we were looking, of course, into things like, what Louis Kahn was doing way back in the days when, with a lot of the things that he was working on, of integrating ideas that would allow for a certain generosity of absorbing changes for the future. What we also found out, which was kind of for us another constraint, was that a chemistry lab building cannot be built purely out of timber because of all the kind of sensitive instruments, the kind of measuring instruments that they have. They cannot actually, have any sense of vibrations in the building. So we were constrained from the very beginning to design a concrete structure. And the search then became about finding ways not only to minimize the concrete, but to really develop this kind of language of the hybrid system that would allow the building to be adaptable in the future. And the building actually had multiple sort of programmatic components to it. It wasn't just the labs, it was also the offices that would be, for the researchers, but also that there would be kind of common areas, conference rooms, meeting rooms, and a kind of public ground floor. So we started thinking about these spatial types and being able to kind of optimize the performance of each one by looking at each one separately, spatially also separately, and that we were able to therefore address the kind of time spans of change according to also the type of structure we would put in. So the labs are arranged quite rationally around this kind of common core where there was a lot of distribution, also shared infrastructure, also where all the kind of services would come up. Their compactness, of course, means very efficient travel distances, less ducts and things like that, and also less material used, but also, in a way, an ease of access of how to get to that kind of infrastructure in order to replace them. So this might seem like a very simple diagram. This is also just to think about, what comes down the line when you start to implement a project into reality, all the kind of coordination that has to happen and the collaboration that needs to happen, and that if we are able to kind of foreground that conversation already quite early on and have really a true collaboration between disciplines, then that logic permeates through the design as well. And so here, this idea that all the kind of infrastructure works together with the structure and the architectural concept became quite central to the organization. And here, of course, you see this rendering of the labs, the wet versus the dry areas, where you see the hybrid structure exposed. Here in the kind of collective zones of the office space. The timber slabs aren't meant only to kind of reduce the carbon footprint, but really also to allow the spaces to be expandable, to be easily connected in the future if, for example, a tenant rents 2 floors or something like that. So this moves the conversation beyond purely seeking efficiency, but towards an idea of sufficiency, but also of, at the same time, sort of architectural generosity. Taking on, let's say, multiple functions and flexibilities. And here on the ground floor, where this kind of mezzanine is a completely timber structural insert that could be taken down in the future to really vacate this kind of large double-height hall for different types of activities that they might bring in there. So maybe just to conclude is that in the format of this short input, it's not really possible to go into detail with any of this and the process, but I hope that I was able to make a bit of a point that to reduce waste and to build better, we have to kind of conceptually include multiple systems into a holistic approach. That architecture isn't a standalone discipline, and if we are to imagine how all of these technologies could help us, then one of the things that I think we would need to think about is how could it help us collaborate? How could it help us bring in inputs from different sources that allows us to also better integrate that into the process of the way that we work, and to essentially, in that sense, extend the lifespan of the resources that we have at hand. Thank you very much.